The first lesson objective is to understand the derivation of the physics equations of motion. Okay, so given an xy axis, and if we're dealing with parametric equations, it's a function of time. So let's assume we have some projectile leave from the origin, in which case it takes a parabolic flight path. So now if we want to analyze and determine the initial position, that's simply just the starting point. This is my x-axis, this will be the initial x value, and this will be the initial y value. Therefore the initial position is just about the origin, or r of 0, which is a vector, will have the coordinates x0, y0. Okay, so this is my initial position at time 0. Okay, to determine the initial velocity, we have to draw a tangent vector from the beginning, or from the origin. Okay, this is the velocity at any given time. And what I can do with my velocity vector is I want to determine, again, just like my position, I want to know the x and y components of velocity. So if I just drop a y component and an x component, I'm going to look specifically for the velocity in the y direction, the velocity in the x direction. And we'll say that we know the initial angle of launch. Okay, so to determine my initial angle, I just have to do, I want to make it look like this. V of t equals the vector v sub x, v sub y. Now I just want to solve for these two values, in which case I just have to do a little bit of trig. I know if I take the sine of the angle, I can get the opposite, v sub y, divided by the hypotenuse, which is v. If I take the cosine of my angle, I know I can get the adjacent, v sub x, divided by my hypotenuse, v, in which case I can rearrange and solve for each one of those components. V sub y is now the sine of theta times v, and v sub x is now the cosine of theta times v. Okay, where v, up here I called it v of t, should actually be a correction, should be v naught. This would be my initial velocity. Okay, so therefore, and this should be initial velocity. Okay. The initial velocity at time equals 0 is therefore v naught cosine theta v naught sine theta. Okay. Okay, now we want to assume once the projectile is set in motion, what forces act upon it. So as it goes in motion, assume this is our projectile, we're going to say that the only force acting on it is gravity. Okay, so here's my assumption: gravity is the only force acting once we set it in motion. This also assumes that wind and drag are negligible. Okay, so if I write out my acceleration vector, I'll have 0 forces in the x direction, and I'll have a negative g, or gravity, acting in the downward y direction. Okay, so now if I want to derive and eventually go from acceleration to velocity to position, first I have to find velocity, and velocity is the integral of acceleration with respect to time. So as I integrate, I have to integrate each piece separately. So the integral of 0 is 0 plus a constant of integration, c sub x. The integral of negative g with respect to time is going to be negative g t plus a constant of integration, c sub y. Okay, so now I want to apply my initial velocity. which case I know v of 0 was v naught cosine theta and v naught sine theta. Okay, so as I apply this initial condition, I deal with the x component initially, so I'll take c sub x is now going to equal v naught cosine theta and minus g times 0 plus c sub y equals v naught sine theta. Therefore, c sub y will equal v naught sine theta. So now my velocity vector is v naught cosine theta, v naught sine theta minus gt. Okay, this represents my velocity vector. Okay, so now to determine position, I want r of t. We're going to denote for our position vector, and that's going to be the integral of velocity. Okay, now again, remember we're integrating with respect to time. In this component there is no time. So as I integrate v naught cosine theta, it's just like integrating a constant. So I get v naught cosine theta t plus my constant of integration. And for my y component, the same thing applies, v naught sine theta t minus, and now I'm integrating gt, minus gt squared over 2 plus another constant of integration. So as I apply my initial position, r of 0 equals x naught, and y naught. Okay, so as I take my x component, v naught cosine theta times 0 plus c sub x equals x naught, in which case this goes to 0 and c sub x equals x naught. And I do the same thing for the y component. V naught sine theta times 0 minus g 0 squared over 2 plus c sub y equals y naught. Okay, in which case these both go to 0 and c sub y equals y naught. So now I can conclude that my position vector is x naught plus v naught cosine theta t, y naught plus v naught sine theta t minus gt squared over 2.